technician most likely connected the coaxial cable from the wall to a live electrical cable on the roof. Yes, a live electrical cable can cause significant damage if connected to a coaxial cable and then to electronic equipment. The high voltage and current can travel through the coaxial cable and into any devices connected to it. The high voltage from the electrical cable caused a short circuit, leading to a bright flash and loud explosion. The surge of electricity burned the cables, electronic devices, and surfaces on the desk. The burning materials produced soot and smoke, filling the room. The cables were forcibly ejected from the computer's ports, and metal bits were scattered around due to the intense heat. The heat melted the silver connectors on the cables, leaving molten metal flakes on the windowsill. The technician's mistake of connecting the coaxial cable to an electrical cable caused a dangerous short circuit that severely damaged the electronic equipment in the home. The electrical wiring system on the roof was also unsafe, contributing to the severity of the incident. Let's delve into the specifics of why this seemingly simple mistake resulted in such a catastrophic outcome. Firstly, understanding the nature of coaxial cables and electrical wiring is crucial. A coaxial cable is designed to carry radio frequency signals, typically at low voltage levels. These cables have a central conductor surrounded by an insulator, a metallic shield, and an outer jacket. Their purpose is to transmit signals with minimal loss and interference. On the other hand, electrical cables are designed to carry electrical power at much higher voltages and currents. In residential settings, these cables are typically carrying 120 volts or 240 volts alternating current. The key difference lies in the voltage and current levels they are designed to handle. When a coaxial cable is inadvertently connected to an electrical cable, the high voltage from the electrical system is immediately introduced into the coaxial cable. This is where the problems begin. The coaxial cable is not designed to withstand such high voltage and current, and the insulation quickly breaks down. This breakdown leads to a short circuit, which is a low resistance connection between 2 points in an electrical circuit that are intended to be at different voltages. Short circuits result in a massive flow of current far exceeding the normal operating current of the circuit. This surge of current generates a tremendous amount of heat in a very short period. This rapid heating is what causes the bright flash and loud explosion that was described. The materials in the coaxial cable, the connectors, and any connected electronic devices are rapidly heated to their melting or combustion points. This is why everything on the desk was blackened with soot and burned either partially or completely. The surge of electricity doesn't just damage the coaxial cable itself. It travels through the cable and into any connected devices, in this case, the cable modem and the laptop. Electronic devices are extremely sensitive to voltage and current fluctuations. A sudden surge of high voltage can instantly destroy the delicate electronic components inside. This explains why the laptop and the external hard drives were rendered useless. The intense heat generated by the short circuit also causes the materials to break down and release smoke and soot. This is why the room was filled with a thick cloud of grey smoke that smelled like gunpowder. The gunpowder smell is likely due to the combustion of plastics and other materials in the electronic devices and cables. The force of the explosion and the rapid heating can also cause physical damage to the surrounding area. The cables were forcibly ejected from the computer's ports because the connectors were literally melted or vaporized by the heat. The molten silver flecks on the windowsill are another testament to the extreme temperatures reached during the short circuit. Silver is a good conductor of electricity and is often used in connectors and other electronic components. Its melting point is relatively high, around 961.8 degrees Celsius or 1763.2 degrees Fahrenheit, so the fact that it melted indicates just how hot things got. The incident also highlights the importance of safe electrical practices, especially when working with unfamiliar wiring systems. The technician's mistake was compounded by the fact that the cable system on the roof was described as a real mess and unsafely stretched over and near an electrical box and associated cables. This suggests that the wiring system was not properly installed or maintained, and that there was a lack of clear labeling or identification of the different cables. In situations like this, it is crucial to take extra precautions to ensure that you are connecting to the correct cable. This might involve using a multimeter to test the voltage of the cable before connecting it, or carefully tracing the cable back to its source to verify its identity. It is also important to be aware of the potential hazards of working with electrical systems and to take steps to protect yourself from electric shock. This might involve wearing insulated gloves, using insulated tools, and turning off the power to the circuit before working on it. In conclusion, this incident serves as a stark reminder of the dangers of electricity and the importance of safe electrical practices. A seemingly simple mistake can have devastating consequences, causing significant damage to property and potentially endangering lives. It also underscores the need for proper installation and maintenance of electrical systems, as well as clear labeling and identification of different cables and wires. Now, let's discuss some preventative measures that can be implemented to avoid such incidents in the future. Firstly, comprehensive training for technicians is essential. Cable installers and other technicians who work with electrical systems should receive thorough training on electrical safety, proper wiring techniques, and the identification of different types of cables and wires. This training should include hands-on practice and regular refresher courses to ensure that technicians stay up to date on the latest safety standards and best practices. Secondly, clear labeling and identification of cables and wires are crucial. All cables and wires should be clearly labeled with their purpose and voltage rating. This will help technicians quickly and easily identify the correct cable to connect to, reducing the risk of accidental misconnections. Color coding can also be used to further differentiate between different types of cables. Thirdly, regular inspection and maintenance of electrical systems are essential. Electrical systems should be inspected regularly to identify any potential hazards, such as damaged wiring, loose connections, or overloaded circuits. Any problems should be promptly repaired to prevent accidents. Fourthly, the use of appropriate safety equipment is critical. Technicians should always wear appropriate safety equipment, such as insulated gloves, safety glasses, and insulated tools when working with electrical systems. This equipment will help protect them from electric shock and other hazards. Fifthly, a lockout/tagout procedure should be implemented. Before working on any electrical system, the power to the circuit should be turned off and locked out using a lockout/tagout procedure. This will prevent the circuit from being accidentally energized while work is being performed. Sixthly, the use of ground fault circuit interrupters or GFCI outlets can provide additional protection. GFCI outlets are designed to detect ground faults, which occur when electricity flows through an unintended path to ground. When a ground fault is detected, the GFCI outlet will quickly trip, cutting off the power to the circuit and preventing electric shock. Seventhly, it's important to use a multimeter to verify the voltage of a cable before connecting it. This simple step can help prevent accidental misconnections to live electrical wires. Eighthly, always trace the cable back to its source to verify its identity. This will help ensure that you are connecting to the correct cable and not accidentally connecting to a live electrical wire. Ninthly, it is important to be aware of the potential hazards of working with electrical systems and to take steps to protect yourself from electric shock. This might involve wearing insulated gloves, using insulated tools, and turning off the power to the circuit before working on it. Lastly, if you are not comfortable working with electrical systems, it is always best to call a qualified electrician. Electricians have the training and experience necessary to safely work with electrical systems and can help prevent accidents. Now let's consider the role of building codes and regulations in preventing electrical accidents. Building codes typically include detailed requirements for electrical installations, including the type of wiring that must be used, the size of the circuit breakers, and the placement of outlets and switches. These codes are designed to ensure that electrical systems are installed safely and correctly. Regular inspections by qualified electrical inspectors can help ensure that electrical systems comply with building codes. These inspections can identify potential hazards and ensure that they are corrected before they cause an accident. In addition to building codes, there are also various safety standards and regulations that apply to electrical equipment and installations. These standards are developed by organizations such as the National Electrical Manufacturers Association and Underwriters Laboratories. Compliance with these standards can help ensure that electrical equipment is safe to use. Electrical safety is a shared responsibility. It is important for homeowners, tenants, and contractors to all be aware of the potential hazards of electricity and to take steps to prevent accidents. By following safe electrical practices and adhering to building codes and regulations, we can help create a safer environment for everyone. Let's also talk about the legal aspects and liabilities in such situations. In this particular scenario, the cable company acknowledged responsibility for the accident. This implies that they recognize their technician's negligence led to the damage. Typically, companies are liable for the actions of their employees if those actions occur within the scope of their employment. This is based on a legal principle known as respondit superior, which means let the master answer. If the technician's actions were deemed negligent, the cable company is likely responsible for covering the damages. The homeowner could potentially pursue legal action against the cable company to recover compensation for the damage to their property. This could include the cost of repairing or replacing the damaged equipment, as well as any other expenses incurred as a result of the accident. To successfully pursue a claim, the homeowner would need to provide evidence that the technician's negligence caused the damage. This could include photographs of the damage, expert testimony, and documentation of the expenses incurred. The cable company's insurance policy would likely cover the damages in this case. Most companies carry liability insurance to protect them from financial losses resulting from accidents caused by their employees. It is important to note that the legal aspects of such situations can be complex and may vary depending on the specific circumstances and the laws of the jurisdiction. It is always advisable to consult with an attorney to discuss your legal options. To further clarify, negligence in this context means that the technician failed to exercise the level of care that a reasonably prudent person would have exercised under the same circumstances. In other words, the technician's actions fell below the acceptable standard of care. Connecting a coaxial cable to a live electrical wire is a clear example of negligence, as it is a dangerous and potentially deadly mistake. The homeowner also has a responsibility to maintain their property in a safe condition. If the electrical wiring on the roof was in a hazardous state, the homeowner could potentially be held liable for contributing to the accident. However, in this case, the cable company appears to have accepted full responsibility for the incident. It's important to document everything. The homeowner should have kept detailed records of the accident, including photographs, videos, and written notes. This documentation can be invaluable in pursuing a claim against the cable company. The homeowner should also notify their insurance company of the accident. Their insurance policy may provide coverage for the damage, even if the cable company is ultimately responsible. Seeking legal counsel is crucial. Consulting with an attorney can help the homeowner understand their legal rights and options. An attorney can also assist in negotiating with the cable company and pursuing a claim for damages. While the cable company accepted responsibility, that does not prevent the homeowner from seeking legal remedies. The homeowner can still pursue a lawsuit if they are not satisfied with the cable company's offer of compensation. These type of situations underscores the importance of having adequate insurance coverage. Homeowners insurance can protect you from financial losses resulting from accidents and other unforeseen events. To touch on safety regulations, there are a multitude of regulations that govern electrical work and cable installations. In the United States, the National Electrical Code, or NEC, is the most widely adopted standard for electrical installation. The NEC provides detailed requirements for wiring methods, overcurrent protection, grounding, and other aspects of electrical safety. Many local jurisdictions adopt the NEC as part of their building codes. In addition to the NEC, there may be other state and local regulations that apply to electrical work. These regulations may address specific issues, such as the licensing of electricians or the inspection of electrical installations. Cable companies and other contractors that perform electrical work are required to comply with all applicable safety regulations. Failure to comply with these regulations can result in fines, penalties, and even criminal charges. Safety regulations are constantly evolving to address new technologies and hazards. It is important for electricians and other workers in the electrical industry to stay up to date on the latest regulations. There are also industry standards developed by organizations such as the Institute of Electrical and Electronics Engineers, or IEE. These standards provide guidance on best practices for electrical design, installation, and maintenance. Compliance with these standards can help ensure that electrical systems are safe and reliable. In this specific instance, connecting the coaxial cable to the electrical system would be a violation of multiple sections of the NEC. One potential violation involves improper grounding. The NEC requires that all electrical systems be properly grounded to provide a path for fault current to flow back to the source. Connecting a coaxial cable to the electrical system would disrupt the grounding system and could create a shock hazard. Another potential violation involves improper wiring methods. The NEC specifies the types of wiring that can be used for different applications. Connecting a coaxial cable to the electrical system would violate these requirements, as coaxial cable is not designed to carry electrical power. Overcurrent protection is another key aspect of electrical safety. The NEC requires that all electrical circuits be protected by overcurrent devices, such as circuit breakers or fuses. These devices are designed to trip and interrupt the flow of current if the current exceeds a safe level. Connecting a coaxial cable to the electrical system could overload the circuit and cause the overcurrent device to trip. This could create a fire hazard. Also, the NEC addresses working clearances around electrical equipment. The code requires that there be adequate working clearances around electrical equipment to allow for safe operation and maintenance. Obstructions in the working space can create a hazard and make it difficult to perform work safely. Also, using the correct type of cable and connectors is paramount. The NEC specifies the types of cables and connectors that can be used for different applications. Using the wrong type of cable or connector can create a hazard and could lead to equipment failure. Consider the arc flash hazard. An arc flash is a dangerous electrical explosion that can occur when there is a short circuit or other electrical fault. Arc flashes can generate intense heat and pressure and can cause serious burns and other injuries. The NEC includes requirements for arc flash protection, such as the use of personal protective equipment or PPE. It's also important to consider surge protection. A surge is a sudden increase in voltage that can damage or destroy electronic equipment. Surges can be caused by lightning, power outages, or other electrical disturbances. Surge protection devices can help protect electronic equipment from damage caused by surges. Finally, there's the topic of electrical inspections. Electrical inspections are conducted by qualified electrical inspectors to ensure that electrical installations comply with the NEC and other applicable regulations. Electrical inspections can help identify potential hazards and ensure that they are corrected before they cause an accident. These are some of the important aspects of electrical safety and electrical regulations. In summary, this incident was a serious electrical mishap with significant consequences, which underscores the importance of proper training, adherence to safety regulations, and responsible electrical practices.